Welcome to our 9-3 video. Our lesson essential question is, can I rotate two-dimensional shapes to create three-dimensional shapes, and can I find the volume of three-dimensional solids? So to recap what we learned about in our class activity, we had some shapes, we put them on pencils, you spun them on your finger and made it go into a circular shape. The radius of my new shape is going to be the radius, or half, of the paper. And this is only going to be if the paper goes both ways. If I only had this portion of paper and I didn't have this, then the radius would be equal to the full paper. The diameter is going to be equal to the full paper. And our height of our solid will be the same as the height of our paper. And the shape will always be circular. Be it a cylinder or a cone or a sphere, but I'm never going to get a cube or something like that with edges. Moving on, we're going to learn to draw some three-dimensional shapes. The easiest thing to do is use this isometric paper. Have your shape already drawn. Start at a corner, and these dots, I like to view them as using it as like slope. So I'm going to go up 3 over 2, and I'll connect that with a line. Then I go up 3 over 2, connect that with a line. Up 3 over 2, connect that with a line. And you can see how this is now forming. Then this is a 3 by 3 shape, so I can then connect like this. And if I wanted to, I could say, oh, let me do the dashed line underneath. And then I could do the up 3 over 2 there. So this is a much nicer way to draw using the isometric paper. Once again, use a straight edge if you're going to be using this. So let's get into finding volume of three-dimensional shapes. So here's our worked example from page 662. To derive the formula of a volume of a cylinder, you can think of the cylinders as infinite stacks of disks, each with the area pi r squared. So that's just going to be one disk here. I can stack, 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 and make it a three-dimensional height. So the height then of my disk will be the height of my cylinder. So to do the math here, or what we're trying to get behind, is I'm going to have a base, and that's the base of the area. So it's a circle, it's a rectangle, it's a triangle, whatever shape, and then you take that and you multiply it by whatever the height is. So here's another picture of this. So here is my triangle. So that would be a bunch of triangles here. So the base, the area of a triangle would be 1/2. And I guess here if I said base times height, and then I had my height of here. So I'm not going to use base times height. That's going to get a little confusing. Let's say 1/2 length times width times height. So length times width, 1/2, that's the area of the base, times by height. Area of a rectangular prism, I'm just going to go length times width, that's the area of my base, times by height. And then the one we already did, area of a circle is pi r squared, and then the height times at the end gives me that volume. Little side note, these are all going to be in units, so we'll say it's centimeters, centimeters, and centimeters. So the area of centimeters times centimeters gives me centimeters squared. And then when I add the height centimeters, I get centimeters cubed. And all volumes will need to be in cubic units. So let's try one right here. So I'm going to have my equation. I'm going to remember that this is pi r squared times height. My radius is 8, so I have pi times 8 squared times height of 24. I'm going to get out my calculator. 8 times 8 times 24 times pi gives me 4,825.5, and the units are important. Centimeters, it's volume, so it's cubed. So, to recap, find whatever the base shape is, take the base times the height. So, here's one for you guys to try. Pause the video and try it. All right, welcome back. So this one is semi-tricky, but I think you guys can figure it out. First, we have to identify what shape it is, and it is a triangular prism. So the base is going to be the triangle. The base is actually this triangle here. Now, it's not sitting on the base. The base it's sitting on is this rectangle of 3 by 8, but the height of that shape, if I go higher, the width, the base changes shape. So I can't use this rectangle as the base. This triangle stays the same whether it goes the whole way or not. So my length and width are going to be 3 and 4. My height is going to be 8. I don't get to use 5 on this equation. 2 times 3 times 4 times 8 is going to give me 48. Remember our units of centimeters, it's volume, so it's cubed. Another thing that's to learn is oblique. So this is a regular prism. An oblique prism is where I take the top and I sort of push it over and it angles. And the cool thing about this is if I have this stacked with a bunch of pieces of paper and I push it over, the volume is the same. So it's the exact same equation as the regular one. It's a right cylinder or an oblique cylinder where there's this angle here is in a 90-degree angle. So I just did the same thing. So why don't you pause the video and you try this one. Hey, welcome back. So hopefully you guys got this equation of the base is the circle, which is pi r squared. Height is the height. I get radius is 5, so I have pi times 5 times 5 times 10, which gives me an area, a volume of 785.4, and there are no units given in this problem, but I'll still write units cubed. So that is our video for lesson 9.3. Good luck on the math via Delta Math, and remember, how can I rotate 2D shapes to create 3D solids, and can I find the volume of 3D solids?